Let's start by asking ourselves, what is reinforcement learning, or in short, RL? Reinforcement learning is an area in machine learning that involves an agent, an environment, and the interactions between them. The goal of the RL is to train an agent to become an expert in its environment. The agent's goal is to maximize the reward it receives from the environment by learning what are the best actions it should take in certain states of the environment. This might sound complicated, but we will break it down through an example. Let's look at an example for a self-driving car in a straight neighborhood street. The reinforcement learning agent in this case is the car, and the environment is the street. The goal is to train the car to drive from the start to the end of the street. The car has knowledge of the set of actions it can take, which are gas, brake, and turning the steering wheel. Every action the car takes in the street results in a new state of the car. For simplicity, we will assume that the car can observe the distance left to the end of the road and the sidewalks. Now, the agent can have zero knowledge about what the goal is and zero knowledge about the environment dynamics. This is called model-free reinforcement learning. We will learn more about the different types of RL in future course. Up until now, this seems like an impossible task for the car. How do you think the car can build the knowledge to drive across the street safely? Well, for every action the car takes in the environment, it receives a reward value. This value shows the car that the action it took in this state was a good or a bad one. For example, if the car moves forward and does not hit anything, the environment sends a positive reward. But if the car turns and speeds toward the sidewalks, it receives a very bad reward. Through those trials and using advanced machine learning algorithm, the car can build the knowledge and find the correct policy to use to choose the proper action that will maximize its final reward. We can apply the same concept to video games, medical applications, computer security, and even space exploration. To give you a taste on how good these algorithms can get, we will try to beat an RL agent in the game of Super Mario. In this game, the agent is Mario and the environment is everything within the game. The agent has learned through millions of training cycles how to play this game in the optimal way to finish each level in the shortest time possible. You will now try to play the game to finish level 1 faster than the RL agent can. The agent finished level 1 with 347 seconds left on the clock. Can you beat that? See you in the next video.